Hello everyone, welcome back to Sailor School. This is the first video of the playlist called Tankers for Non-Tanker Guys. This series of videos will concentrate more on chemical tankers, their operations, and the publications and other documentation related to functioning of a chemical tankers. So this video being the first part, we will be talking about publications, which is international code for the construction and equipment of ship carrying dangerous chemicals in bulk, shortly known as IBC code. So we will be starting this video from scratch, asking the most basic question: what are chemical tankers or chemical carriers? A chemical tanker is type of a tanker ship which is designed to transport chemicals or noxious liquid substances in bulk. So even in Marpol Annex 2 there is a definition for chemical tanker. It states that chemical tanker is a ship which is constructed for carrying bulk liquid products which are listed in chapter 17 of International Bulk Chemical Code. Our chemical carriers are basically differentiated into two types on basis of their chemical carrying, on basis of the mode of chemical carrying throughout the lifespan of the ship. Chemical tanker can be known as exclusive chemical tanker. The exclusive chemical tanker means a chemical tanker which is made to carry one cargo or certain grades of the same cargo on the ship throughout its lifetime. For example, ammonia carrier is an example of exclusive chemical carrier. So you are carrying a particular chemical. And the other type is parcel chemical tanker. Parcel chemical tankers are chemical tanker which carries various parcels of cargo. That is, they can carry multiple cargo or multiple grades of different cargoes on the same ship at a single time, which is also known as product carriers. All of you guys must understand that before the introduction of IBC or BCh code, SOLAS chapter 7, which talks about carriage of dangerous goods, and Marpol Annex 2, prevention of pollution by noxious liquid substances in bulk. So these were the two conventions and their regulations which were directly affecting the construction operation of a chemical tanker. Alright, so what happened is later both the regulations present in these convention were combined together to form a separate code for chemical tanker. So that code before 1986 it was known as BCh code, which later evolved as IBC code. So please understand, before we proceed further deeply into this topic, I would like to give you an outline of the topic, how I will be teaching, so that it will be easier for you to follow my words till the end. We will be talking about different ship types and different types of tank on chemical tankers, and also we will be discussing briefly about tank construction standards in a chemical tanker, and also we will be talking about categorization of cargo of chemicals, starting with types of chemical tanker. Ships of different types range on basis of their size and their capacity, but our chemical tankers have an additional restriction or regulation to be followed when we are constructing it. Chemical tankers are divided into three different types: type 1, type 2 and type 3. Type 1 is a ship which is basically consists of double hull and has an approximate dead weight of 4,200 metric tons. Most of you can notice that the length overall of the ship will be ranging approximately about 96 meters or so. Type 1 chemical tanker is only focused on carrying cargoes which are very dangerous to the environment. So hence this cargo requires maximum protective measures to prevent the cargo from spilling or getting polluted into the marine environment. Type 2 chemical tanker, it also consists of typical double hull of the ship, but the deadweight of the ship ranges from 13,500 metric tons approximately, and the length of the ship is almost 140 meters. Type 2 chemical tanker is built to carry chemical cargoes which have less severe environmental and safety hazards. So it doesn't require extreme preventive measures, but you can say that it requires a significant amount of preventive measures to contain the cargo and avoid pollution. Type 3 chemical tanker contains a double hull ship, and the deadweight of this type 3 tanker ranges from 40,000 to 42,000 metric tons, and the length overall being 180 meters. Type 3 chemical tanker is built to carry chemical cargoes which have very less environmental effects when they are exposed to environment. Type 3 chemical tanker, the way the ship is built is not focused on containing the cargo, but it is focused on maintaining a moderate degree of containment to increase the survival capability of the ship in a damaged condition. Which means even if the ship gets damaged, it must be able to withstand the damage without getting capsized. So this is the main focus. But when it comes to type 1 and type 2, they focus more on the containment of the cargo. Even when the ship is damaged, the cargo should not get outside the ship's hull. So that's what they focus on. Whereas type 3, even the cargo is going out, it is not an issue to the environment because it has very less or minute effects to the environment. So in this case, they will concentrate more on ability to keep the ship without sinking. So until now we talked about chemical tankers. Chemical tankers, we understood what are chemical tankers, what are the types, everything we understood. So before we proceed further, I would like to ask you some question. How do you think these chemical tankers came into the act? Means chemicals could have been carried through containers, through general cargo ships. Many things could have been done. There were alternative methods to carry chemicals in a much safer manner. But why did these chemical tankers came into light, or why did they start to develop? In the present era, everything, each and every item which we use in daily life contains a minute particle of these chemicals which are being shipped in product tankers today. So basically what I'm trying to tell is chemicals were the most required element of a country, whether the country needed to develop or if the country needed to destroy itself. Chemicals were the catalyst. During 1970s, that is when maximum industries were being born everywhere in different countries in different times. Actually, starting from 1970s, it was known as industrialization period, where they understood and they found new and many different kinds of chemicals which can make work lot easier and improve mankind. But chemicals are always have been a major hazard to the environment, even if it has a very less effects towards the environment, but still it has some effect to the environment. So chemicals were always a threat to the environment. So 1970s industrialization happened. That is when other countries needed the chemicals or substances which were very much required for their development. So that's when product carriers or chemical tankers were born, which were designed specifically to carry the chemicals very much needed by the country's economy in during those days. And all of you might think, if you need some chemical, why can't you start manufacturing in your own land? First, all of you must understand, the USA and the Russia were major countries which they themselves started producing chemicals of various ranges so that they could sell the same chemicals to the other countries. But it didn't come with free of cost, or it was not safe. There were a lot of disadvantages or effects due to these chemical factories. Because of getting exposed to those chemicals since ages ago, people are now facing a crisis like cancer and other skin diseases, which were the late effects of such exposure to such chemicals. All of you might be remembering the Chernobyl disaster, which took place in 1986. It was a very huge nuclear disaster which took place somewhere in Ukraine. So, after this disaster, members of UN Council, who were also part of this IMO committee, they decided that the similar stringent requirements must be launched for shipping of any chemicals, because they understood the effects of nuclear waste and effects of the chemical. People started to understand and gain knowledge. They started to become aware of its effects. So what they did was, even for shipping any chemicals, they wanted to provide a platform or a basement of principles and regulations so that it can be shipped safely. So before 1986, were the certain regulations which were merely a recommendation to the chemical tankers. This is known as BCh code. So BCh code only applicable for ships that were built to carry chemicals and which were built before 1st July of 1986. But after 1986, that is after the Chernobyl period, they thought that they needed much more severe regulations for this transport of chemicals. So what they did was, they launched an IBC code which is applicable to ships that are built after 1st July of 1986. So now let us understand what is BCh code. BCh code is nothing but an predecessor of the IBC code. Means before IBC code, BCh code was in power. All of you must understand, when IMO launched this BCh code, they really didn't have any idea about the severe effects of chemicals when transporting chemicals, or if chemicals exposed to marine environment. They did not have any idea how each chemical will have its own effect towards the environment and what is the severity of such effects. They didn't have any knowledge. So basically, with the little bit knowledge which they had, they made the regulations of BCh code and launched the code as a recommendation. If you are loading any chemical in the chemical tanker, you are supposed to have a thorough knowledge of these recommended rules. Means they are just a recommendation but not a mandatory rule. Little bit adjustments could be done. Everyone must note this point, that when there was a loophole in the BCh code itself, there was a point which stated that the code will be kept under constant review, taking into account both experience and future developments with regard to bulk carriage of dangerous chemicals. There were many new types of chemicals that were being produced or that were being invented, and people did not know the severity of these chemicals. So that is when the BCh code, they were already telling that our code is only for recommendation, but when you're carrying an unknown chemical or chemical from our recommendation, it is by your own risk. So this is what the BCh code meant, and this was beneficial for the ship owners because they were able to ship more cargo. There were less stringent rules in regard to the chemical cargoes. So ship owners were able to make a lot of money just by transporting chemicals. So during this 1986 period, the BCh wanted to convert into IBC code, but most of the countries were not happy. Countries in sense, most of the major ship owners were not happy with much stringent requirements and regulations which were put forward through IBC code. So this was a loss for the ship owners because they had to change the entire construction of the tanks, they had to stick with the amendments, etc., and they were not able to ship more cargo. Many stringent regulations were there. Some of the countries initially did not accept to these regulations. There was constant disputes. So some countries said that we will be accepting BCh code regulations itself. Eventually, this mode of transition from BCh code to IBC code to be accepted by all the countries it took some phase and it took certain period of time. But IMO made sure that whichever ships that were built after 1st July 1986, they were built on the basis of IBC code. So we talked about how BCh code got converted into IBC code. Let us understand what were the things that were included in the IBC code also. So IBC code mainly included list of cargoes that were considered as noxious liquid substances under MARPOL, and under chapter 7 of SOLAS, these cargoes also known as dangerous goods. So both these cargoes they combined and they made a list of such cargoes under chapter 17. If any cargo is not there under chapter 17, it was included in chapter 18, which was other substances. 17 was categorized into three different groups XYZ, which we will be discussing later, and 18 is our other substances. So now let us look into tank construction. Just now imagine you are a ship owner of a product carrier. You are going to buy a new product carrier. Just keep in mind you are going to buy a new product carrier. Okay. First thing is that what type of tank will you be using? That will be in your mind. I will be talking about this now. Okay. What type of tank you will be using, and after that you will think about how long will you be using the ship for, and what are the cargoes will you be carrying in that ship, and how long can you maintain, how many years are you expecting the ship to run efficiently. All these things you will consider for mode of usage. Finally, even though if you are a greedy owner, there is something called law. These are known as construction standards of the ship, which is provided inside the IBC code. So even if you have too much greed for money or too much greed to carry more cargo, final picture or final settlement will be through IBC code. Now let us begin with our types of tank. There are basically 4 different types of tank on basis of principle, not on the basis of construction. Principle means we will talk about pressure, we will talk about the forces exerting, etc. Whereas we are talking about construction basis means we will talk about how many centimeter, how many millimeter gap should be there, about that. Okay. First is independent tank. Independent tank is nothing but readily made tanks which contain cargo, and this do not form a part of hull structure on the ship, which means without fitting this tank also your hull will be entirely covered and ship is also seaworthy. If you are removing this tank and throwing it somewhere, still you can run the ship without the tanks fitted. These are independent tanks. So what is the benefit of installing such a tank? This is a particular type of cargo containment system which is developed specifically to prevent or minimize any stress arising due to the stressing or motion of hull structure. Also note that independent type of tank will never allow any transfer of the load pressure to the hull structure, because these tanks are supported by the hull through a system of cradles and support points which absorb all the tank pressure and tank stresses, and they will never allow it to go on the hull. And these tanks are also built with very strong support points to prevent them from slipping forward, astern or side or floating upwards. So they are tightly grabbed and bolted to the ship's hull. Now moving on to the integral tank. Integral tanks are tanks which form a part of ship's hull structure. All the stresses and loads experienced by the tank are similar to that of hull structure. Unlike the independent tank, integral tank is required to complete the hull structure. Without the integral tank, your ship is not seaworthy. Integral tank forms a part of ship's hull, so all the stresses inside the tank are directly transferred to the hull. Now we will be talking about gravity tank. When you consider the bulk cargo, it has a density factor that is 1.2 metric cube per ton, that stowage factor. If it is less than that, it is considered to be a high density cargo. Correct. So when you are coming to the liquid form of such cargo, we will talk about pressure instead of the density of the cargo or the viscosity. We will consider only the pressure of the cargo, which means the pressure inside the tank. Okay. Gravity tank is a tank which has a design pressure of not exceeding 0.7 bar at the top of the tank. Both independent and integral tanks can be gravity tanks. Pressure tank. Pressure tank is a tank which is designed to withstand a pressure exceeding 0.7 bar at the top of the tank. Only an independent tank can be made into a pressure tank. Integral tank can never be made or considered as a pressure tank. So we discussed four types of tanks on the basis of principle. On using these four types, you can usually pair it with at least 8 different probabilities, but only 3 of them are used on chemical tankers. They are independent gravity tank, integral gravity tank, and independent pressure tank. Only these 3 tank types of construction are used in chemical tankers. The construction part I will be discussing with this now. This is required as per the IBC tank construction requirement if you are using a type 1 ship that is used to carry most extremely dangerous cargoes. The difference between the bottom plating of the ship and the bottom plating of the tank must be not less than breadth of the ship by 15 or 6 meters, whichever is lesser. Double shell plating or double hull as of so, the difference of gap between these two hulls should not be less than 760 mm. When we move on to type 2 tank construction, the clearance between the side shell plating should not be less than 760 mm and the bottom plating should not be less than breadth of the ship by 15 or 6 meters, whichever is lesser. And moving on to type 3, it doesn't has any such requirements, but double hull should have 760 mm. Now let us discuss about categorization of noxious liquid substances or bulk chemical cargoes. They are divided into 4 different categories: category X, Y, Z and other substances. Category X talks about noxious liquid substances which, when discharged into sea from tank cleaning or deballasting operations, are deemed to present a major hazard to marine environment. So this is a basic definition of category X. You must be learning everything by heart because the same definition should be written in the examination, as well as the oral examiners will be expecting the same definition. Category Y is nothing but noxious liquid substances which possess a threat to our marine environment, and category Z which possess minor hazard to the marine environment when discharged from deballasting or tank cleaning operations. And other substances are substances which are included only in chapter 18 of International Bulk Chemical Code. And other substances are any chemicals which follow outside the category of X, Y and Z, and they present no harm to the marine environment. The discharge of bilge or ballast water or other residues or mixtures containing only substances referred as other substances should not be subject to any requirements of Annex 2 of MARPOL. Which means if you are discharging the residues of XYZ, you are supposed to comply with the MARPOL requirements of Annex 2. And also, whenever you are carrying these cargoes which fall under other substances category under the chapter 18 of International Bulk Chemical Code, you are not needed to follow Annex 2 of MARPOL when discharging the same cargoes while tank cleaning, etc., because they do not possess any hazard to the marine environment. Now finally, we are talking about contents of International Bulk Code. If you want me to make a detailed video on contents, please let me know in the comment section below. But all of you make sure that you go through all these chapters once. At least the headings you must by heart for the purpose of your oral examinations. So there are total of 21 chapters in IBC code. Each chapter has a special information related to things which are done on chemical tankers, whether it is operation wise, construction wise, electrical installation wise, any arrangement such as pipeline, machineries, pumps, etc., and how to wash the chemical cargoes. So that is it. We have come to the end of this video. As I said before, if you need me to make a video on detailing each and every content, each and every chapter of International Bulk Code, please make sure to mention in the comment below. If you found my video much interesting to and easier to understand, like the video, which will encourage me to make much more videos such as this, and do subscribe to Sailor School for more upcoming content in the near future. Thank you. Take care.